Hello student, very good morning to all of you. I hope you all are happy, healthy and fine at home. Did you remember what were we discussing yesterday? I think we were discussing about the analysis of 1,2-diol, that is a per iodic acid oxidation, and we are generally talking about the structure and the properties of the glucose. And we know that what are the thing we are going to discuss today. Let us look at over here basics of carbohydrates. That is a point of discussion today. So in basics of carbohydrates, first of all, let me recall again. Do you remember what do you mean by the carbohydrate? Carbohydrate means it is a polyhydroxy aldehyde or ketone, or a compound which gives the a compound on hydrolysis gives the unit is called as a carbohydrates. So in that carbohydrate we are talking about the chemical properties of the glucose. As we know that the structure of the glucose, there we have seen number of hydroxyl groups are present. So how that hydroxyl group, so suppose generally how to measure, how to determine or how to infer whether the carbon oxygen or hydroxyl group, if they are present adjacent, means at a vicinal position, it is one of the best technique. It is a old technique to determine the unknown structure of the organic compound, because that time, very long time, there were no modern technique such as UV, IR, NMR, heat core, depth. These are the modern technique available today to determine, to know the structure of the unknown organic compound. And once you know the structure of the organic compound, we can easily find out its physical properties as well as chemical properties. That is the main purpose behind to determine the structure of the unknown compound. So in that way you have to think what type of the hydroxyl groups are present. Yesterday we have seen analysis of 1,2-diols, means per iodic acid oxidation process. From that, after treating that 1,2-diol in presence of per iodic acid, oxidation reaction takes place. It produces some specific type of the end product or the fragmentation which we have obtained. From knowing the fragmentation, we can easily, they were easily come to know that what kind of carbon skeleton is present in the unknown structure they were using for the determination of carbohydrates. So yesterday we have seen, I think, near about the 6 or 7 structures. So finally we have seen when there is in a glucose, everybody knows that the structure of the glucose, one aldehyde group, and alternatively there is a secondary 4 hydroxyl group, and they are separated, and one primary CH2 OH group is present. How that primary OH group is present, that is also we have find out. We already discussed those how to come to know that whether the primary, if we use the reagent like as a strong oxidizing reagent, like as a HNO3, dilute HNO3, dilute nitric acid, producing the saccharic acid, that prove that there is a primary alcoholic OH group is present. Similarly, it is present same reagent treated with gluconic acid. Gluconic acid also gives the end product is a saccharic acid, and this was inferred that there is a one primary group is present. So aldehyde group is proved, or the aldehyde group was inferred from the observation that this glucose, when treated with the mild oxidizing reagent such as Br2 in presence of water, gives the gluconic acid, and it was inferred that the glucose containing aldehyde group, when the glucose are treated with acetic anhydride, gives the glucose pentaacetate derivative, confirm that there are 5 hydroxyl group present in the glucose. Likewise, now by treating this hydroxyl group 1, 2, they are adjacent to each other. How many per iodic acid are consumed? Suppose let us look at here is a glucose, and there we have seen glucose containing 5 hydroxyl group and 1 carbonyl group, which is present in aldehyde, and when this treated with it consume 5 per iodic acid and producing the 5 moles of per formic acid, and 1 compound is a formaldehyde, and from that clearly indicate that the glucose containing the 5 hydroxyl group and 1 oxygen atom, means there are the 6 oxygen atom, they are alternatively placed. That type of the information we can get over here. Now let us look at as a one question I am writing over here. What is that question? When 1 mole of each of the when 1 mole when 1 mole of each of the when 1 mole of each of the following compound is treated with per iodic acid HiO4 per iodic acid, treated with per iodic acid, what will the product be? What will be the products be? And how many moles of HiO4 means per iodic acid will be consumed will be consumed. This is the question. If you read the question carefully, you understand the question first. What is that? I am repeating this question. I am reading the question. Look at here, pay the attention. When 1 mole of each of the following compound is treated with periodic acid, what will the product be, and how many moles of HiO4 will be consumed? That you have to determine. Now I am giving one of each of the example over here, and from that you have to tell me, you have to answer the question. Let us begin with the first molecule I am giving over here. Here CH3, then CHOH, then CH2OH. So this is the molecule, and now you have to tell me how many molecule will consume this structure. This is the structure is given. Look at here, the structure is CH3, CHOH, CH2OH. What you have to focus over here, you have to see the adjacent 1,2 diol, vicinal diol only. Here look at the carbon atom, these hydroxy 1, 2 and 3. At 1 and 2 position there will be a hydroxy group. Here I am purposely written this hydroxy group is a horizontal one. Here is on the upper side, but you have to remember they are adjacent to each other, and therefore it will consume 1 periodic acid. And what kind of the product they will produce? Look at here, CS3, then C double bond O, H acetaldehyde. Another one will give C double bond OH, formaldehyde, means only 1 mole get consumed over here. Understood this? The resulting compound is obtained. One is acetaldehyde, and one is a formaldehyde. That clearly indicate this is the compound where the hydroxyl groups are present, and one we are getting as a formaldehyde, one we are getting as acetaldehyde. That clearly indicate that there is only 1 molecule is consumed. According to the question, when 1 mole of each of the following compound is treated with HiO4, what will be the product? What will the product be? These are the product, and how many moles of HiO4 will be consumed? Only 1 mole get consumed. These are the product, and this is the 1 mole is produced over there. So in this way, that's the answer we can write over here. Now let me give you the second example. The second example of this one is a CS3 over here. CS3, then CHOH, then C double bond OH. Look at observe the structure carefully. What do you see over here? Look at again. CS3, CHOH, C double bond O, they are adjacent. They are at 1 and 2 position. That 1 and 2 indicate the relative position of that hydroxyl group and the carbonyl group. So when it is treated with HiO4, only one mole of that periodic acid required or get consumed and the product. But what type of the product do you get? This bond, the carbon-carbon bond get ruptured, get cleaved, and the resulting, look at here you are going to get CS3, same whatever we have seen in case of the first one. One product is acetaldehyde, another one we are going to get here HO, then C double bond OH, and H is already there. Look at this is what is that? This is a acetaldehyde, which we have written in the same. But what is this? This is a formic acid. This is a formic acid. And how many mole of that per iodic acid is consumed, only 1 mole of that get consumed over here. 1 mole is consumed. Look at over here. So, but the product, one is acetaldehyde and one is a formic acid. Formic acid clearly gives there is a one aldehyde group is there and one hydroxyl group is there. By knowing their what kind of the final product they are producing, from that we can understand what could be the actual structure of the organic unknown compound, right? So by knowing the structure, knowing the final product, we can easily determine the structure of the starting material. What will be the starting material what will be the nature of that starting material, where because the HIO is a oxidizing reagent which is oxidize the bond between adjacent oxygen atom. Remember, if they are present at vicinal position means that suppose as a carbon atoms are there, adjacent carbon atom, this position 1 2 position also known as vicinal position. Here hydroxyl group and carbonyl group present, they are in vicinal position. So that type of the position is called as a vicinal. Now let me take one more example over here. What is the structure? Here is a written like this. Here is a CH2OH, then CHOH, then another one CH2O and CH3. So this is the structure, and when it is treated with per iodic acid, how many moles of per iodic acid should require here to break the hydrogen bond? So that is the main point over here. Look at, observe the structure carefully. What do you see over here? Both the hydroxyl group, they are adjacent to each other. Look at here, 1 2, and here methoxy group is there. Methoxy group is not included in this case, and so that the final product you are going to get over here, it will consume only the 1 per iodic acid, means HiO4. This is a oxidizing reagent. What it will do, it will break, it will cleave the bond between adjacent hydro 1 to diol, and the resulting compound, look at here, the resulting compound we are going to get over here. HC double bond OH, that is a formaldehyde, and another terminal here HC double bond O, then here remaining CH2O CH3. If you observe this product carefully, what do you see over here? How many moles of per iodic acid consume? Look at here, only one adjacent hydroxyl group OH and OH. So finally you are going to get only as a 1 mole here, right? This is a 1 mole consumed by this starting material. So means it indicates that there is a 1 2 hydroxyl groups are present. Now look at as a one more example over here, A, B, C, and now is a D. Here CH2OH, then CHOCH3, then CH2OH. Now and treated with HiO4. Now tell me, observe the structure carefully. What do you see over here? CH2OH, CHOCH3, CH2 and OH. Hydroxyl group is present in the starting material, no doubt about it. But in between there is a OCH3 group is there. That is a methoxy group is present in between two, and hydroxyl group they are present at 1 and 3 position, they are not at 1, 2 position, they are not the 1, 2 diol, therefore there will be a no reaction. So simply you say no reaction. No reaction, no this get consumed, so it remains as it is. So that is the main point you must remember over here. This CH2OH and here OH, they are not adjacent to each other, and therefore there will be a no reaction. Remember that one. Now let us see one more example over here that is give you the idea about how we can analyze 1, 2 diol in that. So suppose this is another one more example. Here I am writing this one, here OH and OH, right? OH. Now it is treated with HiO4, that is a periodic acid. Now tell me, what type of the product do you get, whether there will be a reaction or no reaction? Yes, reaction is going to take place because the hydroxyl group, they are present at 1, 2 position, means they are the 1, 2 diol, and therefore definitely reaction is going to occur and the bond is going to break from here, and one side we are going to get one aldehyde group over here, another side you will get another aldehyde group, and therefore this is the product we are going to get 1,6-diol. Diol Al indicate as aldehyde group is there, and here 1 mole get consumed over here. 1 mole of that HiO4 get consumed, and we are going to get this type of the product, ring opening we are getting over there. So these are the example we are discussing over here, and I hope you are getting this concept very easily. What we can say, let us see another one more example I am writing over here, that is EF, right? Now CH2OH, then CHOH, then CHOH, then C double bond OH. Now I have written this is just 1, 2, 3, 4, 5. Now one more hydroxyl group is there. Let me draw properly here, CHOH and then C double bond OH, and now I am going to use HiO4, that is a periodic. So what kind of the product I must get over here? Look at there, the oxygen atom, whether they are in a hydroxyl or in a carbonyl, but they are adjacent to each other, right? And when 1 mole, now how to count, how to find out the number of HiO4 consumed in the molecule, because they are breaking the cleavage of the bond adjacent, the bond is breaking between the 2 hydroxyl groups are there. So remember here 1 bond is going to cleavage, means 1 mole of that HiO4 get consumed. Look at here, this bond is going to cleave, means 2 moles get consumed, and there is again 1 mole, this bond is going to cleave, means 3 moles get consumed, and again 1 more bond is going to break, means there are total 1, 2, 3 and 4 HiO4, means 4 mole of periodic acid get consumed during this reaction, and the final product you are going to get here one HC double bond OH, that is a formaldehyde. Here you are going to get 1, 2 and 3 are the same, so 3HO C double bond OH, and another here also, here we are going to H C double bond OH, means 4 formic acid, 4 moles of the formic acid, and 1 is a formaldehyde. This is a structure of formaldehyde, and these are the structure of formic acid, and therefore how many moles are consumed? There are 4 moles required to consume to break this molecule into as a different fragmentation. By knowing their nature of the final product, 1 formaldehyde and the 4 moles of that formic acid clearly indicate that this could be the structure of your starting material. So in that way you can find out, you can what we can call it as you can determine the structure of the unknown compound. Let me give you one more example so that you can understood here. Here I am writing again CH2OH, then let me see 1, 2, 3, 4 and 5. So CH2OH, CH2OH, then CH2OH, then CH2 and another OH. 1, 2, 3, 4 and 5 are there. Then you have to find out how many moles of periodic acid get consumed here, that you have to find out. So here let us look at here CH2, CH2OH, 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 not CH2, I think here is a CHOH. Let us see the correction over here, because the carbon never show the 5 bond. Just forgive me over here. Here is the CH2OH, right? But here CHOH, then CHOH, CHOH. That correction you make over here. So remember here, this is the structure. Now we are going to find out how many periodic acid get consumed here, that we are going to find out. Look at here, I am going to, because they are adjacent to each other, this bond is going to break over here. This hydroxyl group, they are also adjacent to each other, and therefore it is also going to break, and this is also going to break, and this, the bond is going to break. Look at here, 1, 2, 3 and 4. So here also as a 4 moles of periodic acid is going to consume here, and the final product, this end, look at this terminal, this on both the terminal there is a CH2OH, primary alcohols are there, and primary alcohol always produce as a formaldehyde is one of the product, like this, means 2, one from here and another from here. Now look at this OH, OH and OH, there will be a 3 OH, means there are 3 moles of formic acid. Here you can write 3 formic acid, and the structure of formic acid, as we know that HO, C double bond OH. This is the structure of formic acid, and how many moles are get consumed? Their total number of moles are required. 4 moles of periodic acid get consumed. So in this way we can answer the question. Likewise, or you can give the justification, or you can explain in this way step by step. So it is a very easy to what is the role of periodic acid over here, and what is the what type of the information it provides us. So that 2 things are important. Here you can note it. And now let us move on to the next point. Next question also on the basis of this analysis of 1,2-diol only, that also we are going to see over here. Let us just see over here what will be the question. Let's see in a moment, shortly we are going to see that one. Let us see question. Next question will be this one. Assign a structure assign a structure to each of the following compound, to each of the following compound, right? This is assign a structure to each of the following compound. Now I am going to give some of the compound. From that you have to assign, you have to find out the correct structure of the unknown compound by providing the information, and from that information they are going to provide you the data. I am going to provide you the data. You have to find out on the basis of your knowledge what we have discussed just now. By applying that knowledge, you have to determine the correct structure of the compound. Let's begin with the first one. Now you have to find out the structure of A, and that structure of A, when it is treated with, it consumes 1 mole of HiO4. It consumes, A is a compound that you have to find out the structure of it. A consume 1 mole of HiO4 and it produce the final products are this one. One is a CS3, C double bond O, acetone, and another one will be the formaldehyde, right? HC double bond O and H. That is the data they have provided us. From that we have to find out the correct structure of the A. We have to find out the correct structure of the A, right? What they did, they assumed that they don't know the structure of A. They treated that A with 1 mole, get consumed, and they got this type of the product over there. So what would be the structure of A? The structure of A should be like this. Suppose you have a structure like this. Suppose, as we know that the role of HiO4 per iodic acid, we know that it breaking the bond between hydroxyl group. If they are present at 1,2 position, they are not breaking other one, oxidizing that hydroxyl group. They must, when that hydroxyl group must be at adjacent position, means at 1,2 position, hydroxyl, either hydroxyl group or either carbonyl group, but they must be adjacent to each other. They must present at a vicinal position. Then and then that carbon-carbon bond going to break, and the resulting compound, the corresponding compound fragmentation obtained in the form of maybe as a aldehyde, ketone, or what we can call it as a acid. Suppose I have taken that this structure, but number of carbon atom doesn't change over here. Remember here. Then suppose I am trying here CS3, C, suppose as a C, suppose OH over here, then CS3 I am writing, then bond, then CH2, then OH, like this. Suppose this is the structure. A must have this kind of the structure. Then and then we can get such type of the fragment. If look at here, when I am treating this HiO4 known for breaking the 1,2 dihydroxyl group 1 and 2. When I am breaking from here, I will get here acetone, and here I will get as a formaldehyde. Then and then this will be the structure of A. Remember, this is the structure of A, and then I will get. So that is the answer of that. Now let me give you second example over here. Second example, suppose here is a B that will be treated with 1 mole of HiO4 producing, what they produce? They produce this molecule H C double bond O, then CH2 4 times C double bond O H, right? This is the product they produce. What could be the structure? What could be the structure of B, right? What will be the structure of B here? What is that? Now as we know that this, you think, because this type of the question require lot of imagination power, lot of thinking power. Whatever we have seen, by applying, if you know, if you understood that concept clearly, HiO4 is a oxidizing reagent which oxidize the adjacent hydroxyl group, and therefore look at here, number of carbon atom 1 and 4, 5, 6 are there. So when these aldehyde groups are obtained, when your structure is like this, this is the structure, suppose as a OH and OH, then you will get as a this. When this structure treated with HiO4, then it will give as a this type of the structure. So in that way you have to think positively or logically what could be the structure of that compound. So let's see another one more example over here. So let's see example. Here is a, let us see third example over here. C plus 1 mole of HiO4 producing this type of the compound HOOC, then CH2 4 times, then C double bond OH, like this. This is the compound which we got after 1 mole get consumed with that C. We don't know the structure of C, but we know the structure of final compound. So what should be the structure of C? Suppose then you have to think the structure of C is how we are getting as a this one. Let's see over here, C double bond O and OH. If the structure is like this, and then the bond is going to break, this side you are going to get acid, and if hydroxyl will produce as a alcohol over there. Remember, so in this way you have to think and you will get this type of the product. So let us see one more example over here. From that you can easily find out its structure over here. Now is example number 4, D plus 1, how many moles here? Here is a compound we are getting over here. Suppose as a, not this one, I think D, then that will be treated with 1 mole of HiO4 gives you this type of the structure, twice HOO, C double bond O, and then here is a C, and then formaldehyde, C double bond OH, and on one side is a formaldehyde. So what could be the structure of D? And the structure of D could be or will be like this, would be like this. The structure of that compound would be like this. Aldehyde means what? 2 moles are there. So here CH2 OH, then C double bond O, then C double bond O, and C double bond OH. Because only 1 moles are required, 2 moles are get here when the bond is breaking from here and the here. so that we are getting only as a, not this one, only from, if it's breaking from here, we are getting 2 moles of C double bond O and the formaldehyde, that type of the compound you are going to get. Now in this way we can find out. So let us see 5E plus 3 moles 3HiO4, and which produce the compound like this one, 2 moles of HOOC, then H formic acid, C double bond OH, and then another one, 2 moles of HCHO, formaldehyde, right? 2 moles of formic acid and 2 moles of formaldehyde. So 3 moles are required. What could be the structure? Do you know that the structure will be like this? The structure of this E will be this one, CH2OH, 1, then CHOH, then CHOH, and then CH2OH. This 2 terminal gives you the formaldehyde, and middle 2 give you the structure of the formic acid. So in this way we can easily determine the structure of the unknown compound. So right, so let me give you one more example over here. Let us see as a example number 6 is there. Suppose as a F again get consumed with 3 moles of periodic acid, HiO4, which produce the compound like 2 moles of formic acid, HCOOH, and plus 1 mole of formaldehyde, HC double bond OH, and plus 1 more of carbon dioxide is evolved during this process. What could be the structure of this, or what would be the structure of this compound? The structures are like this. F has a structure, suppose the 2 formic acid means there are 2 type of aldehyde groups are there like this, CH2OH, then CHOH, then C double bond O, C double bond OH, and this will give you the carbon dioxide, and this will give the formaldehyde, this middle one, and this last one give you the formic acid. So that's why this is the structure of that. And now the finally, what, suppose we have a Z, let us see over here another one more example. From that you can easily find out this one. Let us see here 7 number is a G plus, there is, it consume as a 5 moles of HiO4 and gives the molecule like this, CH2OH, then CHOH 4 times C double bond OH. This type of the compound, if you look at this structure, you might have seen this structure somewhere. This structure is nothing but has a glucose, and therefore G has a structure. G is equal to G has a structure is a glucose. What type of the glucose? As we know that CH2OH, right? The not this one they are producing as a, not this, sorry, let us see the, make the correction over here. It gives 5 formic acid, 5 moles of formic acid and 1 mole of 1 molecule of the formaldehyde, HCHO, that is there, and therefore the structure of G would be the this one, because then CHOH 4 times and C double bond OH. This is the structure which is nothing but as a aldehyde, right? I think with this we have see enough example today. In the next lecture we will see the optical isomerism in the glucose. Let us stop today here. Thank you. Have a nice day.